use mobile phone functionality in real-time execution. So we will talk later about how to apply the test-read mashup application to do the event-based mashup composition. The next section will describe about MIDO, which can be applied to flow-based and event-based composition method first, before we go to another subsections. So first, we would like to give the overview of our description language. MIDO is a description language for integrations of 4 types of components. The first one is mobile application component, web service component. The third one, web application component, arithmetic component, and you can create 3 types of output. There are three types of output that you can configure. You can configure your output as mobile application, test-read web service, and test-read web application. So in fundamental MIDO, composers can add components in flow-based style. The execution will run the process in hierarchical order and produce the final output. So you select your output context first, and you add all the components inside your mashup. And when you execute your mashup, you will run from the start of the flow until the end of the flow and generate the output for the final process. So this is for flow-based MIDO, the flow-based composition method. So the composers are required to perform this task in abstraction process. Composers are required to lay out the abstract model to do something like planning things. And after that, they begin configuration to add all the things. They create the MIDO XML description file by adding all the components and also adding all the configuration of each component. After they got their MIDO XML description file, they upload it to the tool called Mux that can compile the XML file for the output, and later they deploy the output from the compilation process. You will get the application package file, you deploy it on the device, and you execute the mashup. So the abstract model concept for the flow-based composition method is divided into 3 stages consisting input. The input receive input from user or data source. In query stage, the component will execute query to the related data sources. The output stage, the component will display or populate the output message for other devices. After we propose this flow-based composition method, from our first diagram, you can see about BPL on the left-hand side. MIDO can extend the coverage to integrate GUI, web application, web service, data, logic, and the creation of test-read web service, test-read web applications. And you can also use these sensors, mobile applications, and these automated mechanisms such as mashup process scheduling that manage the task for you, and the web mashup session management, and mashup output context transformation, which we will talk later. It's available in MIDO, but these are still problems when the flow-based MIDO cannot cover the event trigger mechanisms and the continuous data stream. So what is the event trigger mechanism and what is the continuous data stream? So the expressibility of fundamental MIDO is that the execution of flow-based mashup is single time. So you execute your mashup and it's only the single time, but some mashups require the real-time update of the data stream and the display elements. For example, a user is moving around with a map, search for a restaurant in real-time setting. So to solve this problem, we apply the flow formalism of MIDO to compose event-based mashup applications. So from the right-hand side, in event-based, it is different from the flow-based. The event-based method application, the containment, input, and query will communicate with each other, not in a flow formalism. So they will do it in background process, and the output display is updated in real-time executions for any integrated component. And in flow-based, the execution order, do not follow the data flow procedure, so you can connect any component with any component, and then it will generate the output in real time. In this method, the integration components first have to be converted as set-read web service output context using MIDO, and then later, after you've got your component, you integrate them with HTML and JavaScript. So we will discuss about this method later in the next section. In the next subsection of MIDO, we present the model and components in MIDO. This can be applied to both flow and event-based compositions. For inter-component communication, we use publisher subscriber messaging pattern. The publisher sends the data, the subscriber, the receipt, and the medium do work, send and receive. So the component can be aligned in serial or parallel sequences. We use integration model to represent the type of integration component. So the integration model demonstrates the type of integration components and the output context, and also the data flow in publisher subscriber pattern. After you have your integration model, when you create the MIDO XML description file, the file will contain the configuration of integration components, all the components that you have, and the configuration of the output context that you like to see in the final process. Next, I would like to explain about the measure components in MIDO. So first, the mobile application component can communicate with mobile applications with Android intent and service protocol. An application name and its execution parameter, name and parameters, have to be configured. So Composer gives the application name and execution parameter in order to execute the component. Noted that the application without name and execution parameters cannot be applied to MIDO. So for example, you use barcode scanner, you give this name and the mode to scan. For map, you give this name and you coordinate. The applications that are compatible with MIDO are listed in 4 categories. We have pre-installed, Google release, and third-party applications that are available for download from the online distribution, such as Android Market or some of the web servers that provide the application online. We also add some custom libraries for testing purpose. And most of the application, if you see in the middle column, it works in input or output state. So there is less mobile application that work in the query state in the middle before the mashup ends. So we provide another application. So in the query process, in the query stage, we use web application component and web service component. The web application components, Composer can reuse parts of any web pages and web applications. So we implemented a tool called the View Extractor to help Composer extract configuration parameters for MIDO from the actual pages. So in the tool called View Extractor, the Composer are able to reuse web application by selecting the extraction element. So you go to, for example, go to Amazon.com, you select some of the elements, and you have the configuration parameters, and you configure the execution parameters. The execution parameters includes clicks from a form submit, take extraction, link extraction, or image extraction. So the parameters are translated to execution code in JavaScript later in the final process. So this is how the JavaScript code will look like in the final process. So